So then the next thing we are going to see is the tracker component that is just a button, because we are just displaying a button, but we could have also the box text input as well if we need there. And then in our application component, you can see there that we have a new array called dev post markers, and that will be an array with all the position of the device, basically when we start getting it from the SDK. Then you will see a method called useInterval, and that's every 30 seconds to get the device position. So this, I will show it to you in a second, is a class that will call some method that we are passing in this callback, this get device position, but it could be anything every set amount of time. So this does a polling to the backend every X amount of seconds. You could do this in multiple ways. You can put this API behind a WebSocket, or put it with GraphQL, or do something else. But in this case, because I want to not build any server code, I just wanted to use my client, I'm polling every 30 seconds. And because the device is sending information as minimum every 30 seconds, it doesn't make sense to have it faster. So this is just for the demo purpose. And then we have this method called getDevicePosition that is getting called every 30 seconds. The first thing is we empty this array with the markers, with the historical information that we are keeping. So we start always from an empty array. And then I will be calling the client getDevicePositionHistory with these parameters, the device ID that we specify on the top of the application.js, or you got from your user, and then the tracker name, that is the tracker that we just created. And then you need to give a start time and an end time. The end time is now. The start time, you can define it. It can be 1 year ago, 1 day ago, whatever. And then we call the client and we get a list of positions, and with those positions, then we can populate our markers that we are going to display in the screen. We need the index to know in which position, we need the latitude, and we need the longitude. And I also like to set the viewport to the last point, so every 30 seconds the screen moves a little bit. So if you kind of move with the point. Then we have the trackers marker, and this is a little component that will be drawing the little points in the map. So we pass the index, we pass the longitude, we pass the latitude, and it knows where to draw it in the map. And we are using this pin component that is drawing a little pin in red with some text that is the index basically in our screen. And then I'm calling these tracker markers inside the map, the React map GL, and basically that's the whole thing. It can have as many markers as we can, and we just get them from there. So this is a very simple piece of code. So now I want to show you these two helper modules that I'm using. That is the pin.js. Basically, it's an SVG drawing with some text that I'm passing and some kind of size, and that's kind of it. And then the setInterval, that is this function that helps me to call a function every certain period of time. You can get this on the internet. There's a million examples on how to do it. Now, if we go back to our website, I press track and nothing will happen because our device is not sending data, because this is a demo. So how I make my device to send data, that's what we are going to work on now. And this you can do from your client application, you can do from your IoT, you can do it as an example like I'm doing. You can do it from wherever you feel that you need to do it. Basically, I will be using the AWS CLI to send tracking information to the location service. So then the location service can get this tracker information and display it in my maps. So for that, I'm going to use this new service that was announced in re:Invent, the AWS Cloud Shell. So I don't need to install anything in my computer. I can use the location service CLI directly from the AWS shell. So that's neat. So you don't need to worry about what is the version of AWS CLI you have in your computer. If you use the Cloud Shell, you're always getting the latest version. For doing this, I created my own script. So every 30 seconds it's sending the location updated for one particular device. And this is very arbitrary. I started with a fixed location, basically a longitude and a latitude. And then every 30 seconds, I'm increasing both dimensions on one, and that's it. And I'm sending that location. So it's very, very arbitrary, but you could do the same from, a client application that is sending the coordinates that it gets from the GPS, or an IoT that is sending the coordinates that is getting from, again, the GPS of the device. The script is available also in the code, so you can go and check it out. You need to pass the tracker name, and you also need to pass the device ID. And then when you call it, it goes forever, and every 30 seconds it sends a message to the location service API using the CLI, and then it waits, and then it again. So the code is very, very simple. So now if we leave this code running for a while, we can press the track button in the website, and we can see what is going on. So then if we put this running with the tracker name, the device name, and we leave it running there, we can go back to the website, press the tracking button, and we can see how the website updates itself with the real-time information from the tracker. I'm speeding up this visualization because, well, getting to point 11 takes quite a long time, every 30 seconds, and I want you to get the idea on how this looks. This will be looking exactly the same for you. So if you leave it running, it will just get over Cairo and keep on going up. And in some point it will fail because look, latitude and longitude are not infinite. So don't leave it running for more than an hour because it might break. But the idea here is to show you a working demo, and you will not send location information like I'm sending. If this is in production, you will send it from a real device with real longitude and latitude. So this will not happen to you when you implement this in production. But I wanted to show you something that is working end to end. That's it for today. I hope you enjoyed the video. In this video, we learned about tracking, we learned what the trackers are, we displayed real-time information in the website, we learned how to use the AWS SDK to get that information. We also learned how to use the AWS CLI to send tracking data from our clients to the location service, and then from the location service to our client using the AWS SDK, and everything without any servers involved. In the next video, we are going to see how to get notifications or how to do something when, for example, a customer is getting inside your store or a package is arriving to destination. We are going to learn how to know all those things and how to send messages. So I see you in the next episode of Fubar. Ciao, ciao!